Very good evening. How are you? Good evening. Good evening. Okay. So till now, we did a lot of machine learning here. We know about supervised learning and see here, students. We had learned in case of supervised learning, we are looking every time for the output. Got the point here? During the supervised learning, we had always learned that there is a mentioning of Y label or target every time. Okay. So if I'm in a data set, I'm having a Y label. X is the input label, but all time I'm looking for the Y label. So those parts will be moving into the supervised learning. But think out a situation where I'm having entire data set with X only. X data means I'm having entire data set with input only. Input data, X data. I do not have any other data. Only input I am having. I do not have any other thing. What should I go for? In that case, I will be approaching unsupervised learning. Unsupervised learning is one of the type of learning we need to consider whenever I have input data only. Only X data I am having. That's all. I do not have any Y data, nothing. Only data, that's all. No Y, no Y. So in that case, I would be moving towards the unsupervised learning. So in case of unsupervised learning, I do not have any Y, no, only input data I would be having. Remember this point, please. Okay, so that is there. So let's see how unsupervised learning works, okay? So basically now, what happens in a very general unsupervised learning, when we talk about the unsupervised learning, it means there is only X data, only input data, there is no Y data. And in this case, we need to consider one of the major algorithm, that one is a K-mean algorithm. What happened inside this K-mean in unsupervised learning creates the clusters basically. When we work onto the unsupervised learning algorithm, they starts creating the clusters. Clusters or group based on cluster or group based on what? Based on to the matching, based on to the pattern matching basically. Nearby numeric matching. Okay. So basically, when we talk about the clusters or grouping, unsupervised learning, K-mean algorithm takes the centroid values on its own to make the clusters. Okay. So let's see how these clusters are formed in case of unsupervised learning, right? Let's see how this K-mean algorithm works, where we can provide the number of clusters, right? You think out, suppose I'm having a huge data set. Think out. Suppose I'm having 5 lakh rows. I'm saying I'm having a data set with the 5 lakh rows. And inside those 5 lakh rows, I'm having only input data, means there is nothing output data. There is no concept of output data. Okay, now for an example, you think out a situation where I'm having a data. I took a data from an apparel industry. Apparel industry means garment manufacturing industries. The companies who are the industry who are manufacturing regular clothes for people. So 5 lakh rows data I received. Inside those rows, okay, only measurements are present. Measurements are present, but nowhere any category is present, nothing. So 5 lakh rows are there. They are related with the measurements only. Body measurements are there. So they make, okay, now how, because what should I do with this data? There's nothing apart from the measurements. There's nothing. So when I interacted, you think out that because what happens, students, here in unsupervised learning, we need to create the group. This is the last option for us, means unsupervised learning. This is the last option for us to create the groups. You cannot define any why, anything, nothing is there. Okay, means here you have to go with the unsupervised learning only and only when you do not have any other option. In your data set, nothing is there, only input values are there. There is no why, nothing to think about. So that data if I'm having, okay. So I took a data where only rows are there, and in those rows, only measurement of the clothes are present. That's all, done. What should I do with these measurements? So that the owner asked me, can you create certain groups of this 5 lakh rows? Or can you create certain approximate groups? So how can I make a group? How can I make a clusters basically? So how can I make a group or clusters? So what we need to do, we need to identify, we need to talk, or we need to identify from the industry owner that, okay, to which type of people you are making the clothes. Suppose he said that we are making the clothes for all size. Means we are covering children's also. We are covering like medium sized cloth also, and we are creating large size cloth also. Means if a person means large size clothes also, we are making that. So this is just I took an idea from the person that what type of clothes they are making. They are making the short size clothes. Short means children size clothes. They create the medium size clothes also, and they are also creating the large size clothes also. So this group they are covering. So from there, I shot one idea that, okay, he's talking about 3 groups. So I can make 3 clusters. 3 clusters means 3 groups. Okay. So here we can apply unsupervised learning K-mean algorithm. Okay. Think out, suppose I'm having a data, that data I'm taking now. Let me plot some data here. Wait. Wait. Okay. So, see, some of the data points I'm making. Okay. So you can see, students, some blue points, some pink points, some yellow points. A mixture of the data are there. Now we need to put them into the cluster. We need to put them into the cluster with the help of unsupervised learning. So here now, when I talk about the unsupervised learning, so here I'm saying I'm using a k-mean algorithm. Inside the, as the name suggests, k means how many number of clusters. Inside the number of k-means, when I talk to the industry person, he told me an idea that they are working for the 3 groups. For the children's also, they are creating the clothes. Middle-sized people means medium-sized, and the larger one. So here inside the k means there is one of the parameter n clusters. So what I can think that I can provide here 3 numbers of clusters. It means what I can do out of these mixtures of the data. Now suppose here I'm saying 5 lakh rows are there. So I can create a 3 group. I can create a 3 group. Now how they are possible to create a 3 groups? So what happens, what k-means algorithm will do? It will automatically select 3 centroid. This k-mean algorithm will automatically select 3 centroid. Remember carefully, 3 centroid value. 3 centroid value means any 3 value. Randomly, it will choose the 3 centroid, because here we do not have any kind of control on unsupervised learning. So suppose for an example, here a lot of measurement values are present here. Cloth measurement values are present here. So think out, suppose you can see, suppose I say, let me take here, suppose, okay, let me take this one. This one is 4.8. This point I'm talking about, this point, 4.8. This one is 4.9, 7.1, 8.2, 9.8, 6.3, 3.3, 2.8, 8.3. So the point is here, I'm just making certain measurement points. Now think it out. What k-means will do? K-means will okay. So this centroid value, what will happen? This here k means will select any random 3 centroid value. So here you think out, suppose for 3 centroid value, the first value chosen by k-means cluster, k-means algorithm is 4.8. This is one of the centroid value. Just wait, please. Now here, there are 3 centroid value I'm talking about. You can see some another points are there. So here some data are related. These data are related. Suppose I say 22.6. Some measurements, I'm just giving it here, 22.6. And here some point is relating with, I say, 42.8. So what happens that k-means algorithm will choose any 3 centroid point randomly. We do not have any control. So one point it has chosen 4.8 randomly, another point it has chosen 22.6, third point it has chosen 42.8. Done. Now what it will do, once it chose 3 centroid value, now it start making the clusters with from all the nearby points, from all the nearby data points here. So suppose here, now 4.8, this point will start looking that which another point is nearby to 4.8 in this area. So here it will look 4.8, 4.9. This one is nearby. So while making the cluster, K means will start making the group. 4.9 is involved into the group. Then any other point is also there. Yeah, 4. This is 9.8. Okay, just wait. 4.9. Any other nearby point is there to 4.8. Yeah, 7.1 is there, which is nearby to 4.8. So here this will be also involved into the cluster. Any other point? Yeah, 6.3. So 6.3 is also involved into the cluster. Any other point nearby to 7.1? This 4.8 or 7.1? Yeah, 8.2 is also nearby to 4.8. Any other point? We are having a 2.8 also, which is nearby to 4.8. So let's take this also into our cluster. Any other near point nearby to 4.8? Yeah, 3.3 is also we are having. So let's involve this one also in our cluster. Any other left out point? Yeah, we are having 8.3. Let's take this one nearby to 4.8. So it means what happens? This K means algorithm will start finding it out all the nearby point which are nearby to 4.8. Suppose I say, suppose this point, see this point. This one is 32. This point is 48. This point is let's say 22. So these are left because they are heavy, they are not nearby to 4.8. So all the points which are nearby to 4.8, so they will be involved into the cluster. Now what happens now? Suppose nearby 100 point it has covered. This 4.8 start looking all the nearby point and it covered 100 points. So once it covered nearby all the 100 points, you think it out, all the nearby 100 points it covered into its cluster. So then it will find out the mean of that. It will find out the mean of that 100 data points. And once the mean is calculated now, suppose I say the mean is calculated as 6.8. So now this is 6, suppose 6.8, this point is 6.8. So now this is 6.8 will be the new centroid point. And now this 6.8 will start looking all the nearby data point which are nearby to 6.8. So they will be start involving into the cluster slowly, all the data points which are nearby to 6.8. So they will be involved into the cluster. Then again, 100 data points are covered. Then again, new mean will be find it out. And suppose new mean is, I say, new mean is coming 8.4. So the new centroid will be 8.4, and then 8.4 will start looking all the nearby data points. This process will goes on till it gets all the nearby points. Okay. Now let's go to the second centroid, this one. K means also selected this point also. So here, what will happen? Suppose 22.6. So 22.6 data point will start looking all the nearby data points. Suppose here 22.6, 21.2, 24.3, 19.4. So all the data points will be started created into the group. The same process is there. Once the top 100 data points are collected together, their new centroid is, their mean is calculated. The mean which is calculated, that would be the new centroid. And then again, new data points will be started collected, which are nearby to that new centroid. The same will be happening to this one also. So it means the group will start creating and finding it out all the nearby data points. Got the point here? So in this way, K-means unsupervised learning will start creating the groups. So what happens at one time now? At one time, what happens? The groups will be created in this way. Your groups will be created. Suppose this is one group. This is another group. This is the third group. Okay. So this is the one group. This is the second group. This is the third group. So three groups are created. First group, second group, third group. So in this way, your K-mean algorithm works. Okay, your K-means algorithm will work. So three groups are created. Okay, and this happens when we pass on the number of clusters, 3. So 3 groups are created. So here there is no hard and fast rule in case of unsupervised learning. In case of unsupervised learning, there is no hard and fast rule. Here the only option is we can create a number of clusters based onto the ideas that how many number of groups could be created. You can call it a cluster or you can call it a group. And this one is just a rough idea. Okay. So here the major algorithm which works is a K-means cluster basically. So you can see here unsupervised learning. Unsupervised learning is one of the technique here when no labels are given to the learning algorithm. There is no label, nothing is there. When no labels are into the learning algorithm, leaving it on its own to find the structure in its input. Okay. Unsupervised learning can be a goal in itself, discovering hidden patterns in data or a means towards an end. In some pattern recognition problems, the training dataset consists of set of input vectors only. We do not have any target values. So there we can just discover the groups. So here comes your unsupervised learning. So we do have the clusterings basically. We can create the clusters here. Clustering. So clustering is an important concept in unsupervised learning. It mainly deals with finding a structure of pattern in a collection of uncategorized data. So here it will be finding it out, the structure or a pattern in a collection of uncategorized data. Clustering algorithm will process your data and find natural cluster or group if they exist into the data. Now, basically, clustering algorithms are applied in many fields, such like marketing, to find out the customer behavior. In biology, classification of plants and animals based on to the given feature. In earthquake studies or certain worldwide documents here. You can see here, suppose this one is a mixture of vegetables. I ask you to make the clusters or groups. So you can make the segregations based on to the same features. You can identify the same features here and we can just make the clusters here. Okay. Distance. Okay. So here basically now we do have clusterings, right? You can see here the types of clusterings. Basically, we have 3 algorithms. K-means, hierarchical, and DB scan. When we talk about the clustering, when we talk about the this particular unsupervised learning. 3 basic algorithm comes here. When we talk about the unsupervised learning, 3 basic algorithm works. K means clustering, where we can pass how many number of clusters. Suppose 3. Then there is a hierarchical agglomerative clustering. And then DB scan. Okay, these are the major one. These are the only one. And the major one is K-means. So here we do have a K-means algorithm. K-means algorithm is one of the simplest unsupervised algorithm that solves the well-known clustering problem here. So here this unsupervised K-means algorithm will make the entire data and find out the similar patterns and start making the groups or the clusters. Basically, the process is same here, that this particular K-means algorithm here, this is the same process which I described right now. Just wait here. That we can provide the number of clusters. Suppose we provide 3. So here 3 centroids will be automatically chosen here. Then they start making the groups, based on to the minimum distances to them. And they keep on doing it. This process, they keep on doing it till they complete all 3 numbers of groups. Once 3 groups are created, or provided number of groups are created, 3, 4. So once the groups are created, the process will be automatically stopped in case of K-means algorithm. Now let's see how we can just call the K-means algorithm. K-means algorithm is already present inside your sklearn. Okay. Inside your sklearn, it is there. So you can import all the library, but you can see here, you need to import here. From sklearn.cluster import K-means. K-means is the major algorithm here. See here, from sklearn.cluster import K-means I had loaded. Currently, for the easygoing here, I'm taking an iris file. But inside iris file, we will not give any output data. Any of the input data we can pass. Any. So here I'm just taking iris.csv. And here I'm taking only 2 columns currently. So here I'm taking, you can say here, petal length and sepal length. Here I'm just passing. Petal length and sepal length here I'm just passing. Petal length and sepal length here I'm passing. So only these 2 input columns I'm passing. No Y is there, nothing Y. Okay, so because K-means does not know any Y. So these 2 columns I had taken, right? Once I took these 2 columns here as an input data, so only petal length and sepal length will go. That's all, nothing more than it will go. I'm just calling K-means. See here, K-means I'm calling. I'm saying, okay, just to do one thing, that inside this data, there is a possibility of making the 3 groups. So I'm generating an idea, and here I'm giving number of cluster 3. Start creating the 3 groups. So I'm calling the K-means, start creating the 3 groups here, then model is there. Then here, model is just an instance I had created for K-means. Now here I'm giving model.fit predict, and here I'm passing the data frame. Inside this data frame here, petal length and sepal length is provided. Okay, petal length and sepal length is provided, right? So only input data I had provided it here, right? And after that here, it will return me Y model. This one is a returning value. So it means it is giving me the groups, right? So it means I'd call the K-means, I'd given the number of clusters, I created the instance, and then in model.fit predict, I'd pass the input data. Inside the input data only, I'm passing petal length and sepal length. That's all. No other Y data I had passed. Now it is returning me the groups. So here it is giving me 3 groups. So here it is saying, see, here it is saying, yes, I am able to identify 3 groups are possible with these provided data. Not only this, 150 rows went for petal length and sepal length here. Okay. So here it is saying, yeah, 3 groups are there. These rows belongs to one group. Another rows belongs to 2 group. And one row belongs to third group where 1, 1, 1 are there. So what are these? It is saying group 1 is there, where this 2 to 2 is mentioned, group 2 is there, and where this 1, 1, 1, 1, 1 is mentioned, group 3 is there. So it is saying I am able to identify 3 groups, and I am saying that these rows belongs to which group. So group 1, group 2, and group 3 I am able to identify here. 3 groups are there. It does not know what is the value, but here it is saying it does not know. These 0, 1, 2, do not compare it with iris setosa, versicolor, virginica, because 0, 1, 2 are not here, those iris setosa, virginica, versicolor. No, no, no. Even this K means does not know who is virginica, versica, nothing, nothing. Because we are not passing any Y here. It does not know what is Y. It is simply giving 0, 1, 2. It is saying 0 belongs to group 1, 1 belongs to group 2, and 2 belongs to group 3. It means I am able to identify, yeah, there is a possibility 3 groups I had formed inside your provided petal length and sepal length data. Here, these are model labels. It means this one model. Now, can you see here model instance? So these are the model label underscore. Here it is showing the same data. This data, now this is the same data. Here it is saying these data and these data are the same data. These are the groups. These are the 3 groups we are able to identify. Now I want to see it here. Here I want to plot it here. Okay, that you are able to identify 3 groups. Can you show me here? So it is saying, yeah, whatever data we are having here, where it is saying group 1 is there. It is saying group 2 is there. Here it is saying group 3 is there. Okay. So here plt.scatter. So here it is saying I'm just passing here df.ilog to columns here I'm passing, and here we can say C is equal to model.labels. It means these labels. And we are passing it here, that kindly put these labels in this format. In point format, and CMap word is means here that kindly take all the data and plot the data with different colors as per the group. Okay, so here it is saying group 1, group 2, and group 3. So from your provided data, we are able to identify 3 values. Okay, so in this way. Now I want to see that from this Y model, this one is a Y model, this one is a Y model, the output, this one. So I want to see, can you tell me how many rows belongs to 3 different groups? Can you tell me? So here it is saying, I'm using value count function. So here it is saying, yeah. Here it is saying we are able to identify 3 groups. Here it is saying one group belong. See, you can take like 0 group, suppose the 0. So you can call it a group 1. You can call this 1 where 1, this is a group 2, and this 2 is basically group 3. So it means 3 groups we are able to identify, 3 groups. And how many rows are there? So here it is saying, yeah, there are 51 rows belongs to group 1. 41 rows belongs to group 2. 58 rows belongs to group 3. Okay. So it is saying that many rows we are able to identify with different groups. Okay, now here suppose I say that can you show me that what are the rows which belongs to one type of group? Suppose here it is saying, can you show me what rows belongs to 0 type of group? 0 means one type of group. This 0, 1, 2, this is nothing. This is saying this is a group, this is a group, this is the group. This is a first group, this is a second group, this is the third group. In this way, you have to understand. Now here, I'm saying, okay, show me how many rows belongs to 0th group. Okay. So these are there. So here it is showing me rows which belongs to 0th group. These are all rows. See here, these are all row numbers. It is showing me that belongs to 0th group, this 0th group. Okay. These are the row number 27, 28, 37, 40, whatever row numbers are these from the data set, because 150 rows are there. From the data set, it is taking these rows belongs to 0th group. Means this is a one group basically. Now there is one group also, because 3 groups it has identified. Now I'm saying, looking at the data points which belongs to cluster 1. So here I'm saying, can you tell that there is a group 1 also, this one. This is a cluster 1. This one is a cluster 1. Can you tell me that which rows belongs to group 2 or cluster? You can call it a cluster 1. You can call it a group 2 also. So here I'm saying DFY model is equal to 1. Yani ki it means you can just tell that these are the rows number which belongs to another group. So how you can identify? Suppose here row number 50, row number 52, row number 676, row number 77, these row number 100, row number 102, these belongs to different group which belongs to 1. So basically nearby, see all these are the row numbers it is showing that these rows belongs to another group, which are mentioned here. Na? 3 groups are there. So 3 groups are mentioned here. Na? Like 58 rows belongs to one group, 51 rows belongs to another group, 41 rows belongs to third group. So those row numbers, it is, I want to see it here, that which row numbers belongs to 0th group, which row number belongs to one group, okay, which row number belongs to 2th group. So in this way we can identify. So this one is basically K-means algorithm. In this way your K-means algorithm works. So K-means algorithm is very good algorithm in this unsupervised learning, which is giving you a number of clusters. Here you can give the number of clusters, or you can give the groups as well. This is the best algorithm, if I say. This is the best algorithm. You can provide here number of clusters. So this is one of the algo. K-means is one of the algo. Okay. I'll tell you what is this. Just wait for that. Now we come to the next clustering. That one is a hierarchical clustering. In hierarchical clustering, how it works, let me tell you. First of all, suppose here the group starts creating in a way. Suppose I'm having points. Suppose these 2 points I'm having, these 2 points I am having, then 1 point here, 1 point here. So suppose these are the points. So here A, B, C, D, E, F. Suppose these are the data points. So here in hierarchical clustering, this one is another algorithm. So here which are nearby data points here. So here nearby data points are A and B. So this will be created as one group. Then it will find out what are other nearby data points. So these D and E are the nearby data points. So this will be framing into the another group. Okay. Then any other data points nearby to AB, this group here? Yeah. This one. Okay. Any other data points to this group? Yeah, this one. Right? So in this way, your hierarchical agglomerative clusterings work. Hierarchical agglomerative clustering is generally a family of clustering algorithms that build nested clusters by merging or splitting them successively. This hierarchy of cluster is represented as tree or dendrogram here. So basically here in hierarchical clustering, you can see how it works. See here, first nearby two data points are created into one cluster. Then this becomes another cluster. Then here it is involving this other data point into its cluster. This cluster is involving these data points into its cluster. And then here it is looking C and D, they are also nearby. So let's involve this one as a big cluster. So in this way, hierarchical agglomerative clusterings works in case of unsupervised learning. So here, tree or dendrograms are also created. See here, just like A and B, na? So A and B. D and E are clustered, D and E are clustered. Then here ABCs are clustered. So ABC already AB done. So ABC, C is also clustered. Then here DE is also clustered, but DE is also clustered with F. So DE clustered with F. Done. And then here C and D's are clustered. So C and D's are clustered. So this one is a tree or dendrogram, we call it. So this one is a hierarchical clustering. So how we can work on it? So for this now, simply we have to call this one. Algos only we have to call. How? From sklearn.clustering, import agglomerative clustering. Okay, I'm loading this data set currently. So here I'm loading it here. So here I'm just taking this data set and I'm passing this only input data here. I'm passing iris.data. That's all, nothing more than. Only input data I'm passing it here. I'm calling the agglomerative clustering.fit, and inside it I'm passing iris.data. Okay, here I'm making the instance. So here it is giving some cluster. You can see here, these two cluster it is saying. It is saying that the data which you had provided now, I am able to find out two groups inside this agglomerative clustering. Because here you cannot give anywhere 3 or 4 groups you cannot give. Like in k-means clustering, you were giving now three number of cluster you were giving it here now. But in agglomerative clustering, you cannot give it. There's no option, no portion where you can give it. Okay, so here it is saying I am able to identify 2 groups only, right? Now here, if I want to plot the data, this data, I am taking plt.scatter. Here I am taking this data 0 or 1. Okay, here I am taking clustering.labels. This one clustering.labels. I am taking it here. Just to plot it here, clustering.labels, and CMap where it is means kindly show it accordingly to the colors. So here it is showing you, yeah, this is one group, this is another group. I am able to identify. So in this way, your unsupervised learning is able to identify 2 groups in hierarchical agglomerative clustering, this one. So this is one of the algo. But what we do use heavily k-means algorithm. When we work with the unsupervised learning, we do use heavily k-means algorithm. That is the best algorithm. There we can give number of clusters. But somehow these are there, so You should have knowledge. Then there is one more DB scan. DB scan. DB scan means density-based scan algorithm. In density-based scan algorithm, you can see here, the clusters are created only to those places where densities are there. Densities means heavy data points are there. Means there should be number of data points. If number of data points are there, if densities of the data points are there, so there the groups could be created, otherwise not. So that's why the name is mentioned here, density-based scan. You can see here, density-based scan, DB scan. So where the data points you can see, suppose you can see here. Can you see here these 3 points? These 3 points will not be involved into the cluster because they do not have a density of data points. Only 1, 2, 3, no. So only group will be created only where heavy densities are there. This one. This one. Okay, so this is there. Right. So density-based algorithm will start making the cluster only where densities are there. If heavy number of data points are there, it will make the cluster. Otherwise, it will leave the clusters. It will not make any clusters. Take care for that one. So the DB scan algorithm view cluster as areas of high density separated by areas of lower density. Okay. So here now, here you can see DB scan takes 2 parameters to find the cluster in the data set. One is cluster radius and minimum numbers of data points. It means what it does, just to make the cluster, it will start finding it out the data points that there should be at least minimum 5. Suppose this is the data. So it will start looking out all the nearby at least 5 data points. Means if 5 or more data points are there, they would be involved into the clusters. And the minimum distance, the radius, should be nearby. It will not involve this one. Not. So this would be the cluster. So in this way, your density-based clustering will be there. Okay. So from sklearn.cluster, import DB scan. From sklearn.dataset, I just call this load iris dataset and load the input data only inside the DB scan. So it is just returning me db.labels. So let's see. You can see here, it is just giving me some cluster. See this cluster 0, 0, 0. These are the cluster it is framing it. So basically what it is doing here, this is showing this 0, 0, 0, 0, 0 as one cluster. This is one cluster. One cluster or a group, you can say. This is one cluster or a group. You can see some of the values such as 1, 1, 1, 1 I am talking about, 1, 1, 1, 1, 1, 1, 1, 1. So these 1, 1, 1 values belongs to group 2. Group 2 or cluster 2, you can say. This is the second cluster. Now there are certain -1 values. You can see a lot of -1 values are there. -1s are basically noise sample. What are these noise sample? These are noise sample. These are faraway values. The values which are here, This one, see this one, these are -1, -1. Because they do not involve in any cluster. They are far away values. So they will never come into the cluster in TB scan. Okay, so in this way, this TB scan is working. But here the best approach is use k-means. K-means is the best algorithm to work in case of k-means algorithm. Okay, this is TB scan, hierarchical clustering, and the above one is a k-means algorithm. These are the major one. Got the point here? These are the major three algorithms I told you. Now there is no one point here. When we talk about the k-means algorithm, suppose this one is k-means algorithm here. So here we are providing number of clusters based on the knowledge of the data set, the knowledge which we are gaining from the data set. From there we are getting the idea, or by making the conversation by the person from where we are getting the data set, or studying the documentation that what is this data set about. From there we are getting that idea that how many clusters we can create it, how many number of clusters. There is no matrix, nothing here in case of this, because this is, we are doing just random. There is no supervised learning rules are there, nothing is there. But here now that if I provide here number of cluster 4, it will start making 4 number of clusters. So the point is here now that how we can identify that how many number of clusters we can make it. Okay, so for that now there is one more idea. Let's see, currently here I am giving randomly number of cluster, create 3 or 4 in this way. So there is now one more idea, elbow method. This is a technical idea that how we can select the number of clusters. So we call it a elbow method. That how many number of groups could be created, how many number of clusters could be suggested. So we can take this also, right? How, let's say now. So here elbow method is also there. This is a technical idea which we can take to make the number of clusters. In k-means algorithm, we can take it. So here now what happens in elbow method, you can see, to evaluate the performance of our k-means algorithm, we can take a look at the inertia or objection function value. This is essentially the sum of square distances of our data points are away from their cluster centroid. By looking at different inertia value for different numbers of clusters, we can make it. So first of all, we need to find out inertia. To finding out the inertia, we need this formula. We need to work on this formula. This formula is what? Within cluster sum of square, WCSS. WCSS is defined as the sum of squared distance between each member of the cluster and its centroid. So this one. So basically what is this? This is nothing, this is very easy. See here, let me tell you how this is working. Very simple way, very easy. Suppose here, how it is working. Suppose this is the chosen centroid. So there are number of data points. Suppose this is a data point. This is the data point. This is the data point. This is the data point. So how far away? How far away? This one. This one is a centroid. So this one is, I'm saying x1, x2, x3, x4. So it means how far away is the distance of centroid from these data points? How far away the distance of the centroid point from this data? So basically, suppose this is the distance. What is the distance here? x1 minus c. This one is x2 minus c. C is centroid. This one is x3 minus c. This is x4 minus c. C is centroid. So it means xi minus ci, making the square of it and add them together from I is equal to 0 to n. Once it is calculated, that is your WCSS. WCSS is within cluster sum of square. So once this value is created now, this one is also known as the inertia. Done. Okay. So these are there basically. So this will be calculated. So you can see here, we can call it an intra-cluster distance also here. So you can see here, for each value of k, we will initialize k means and use the inertia attribute to identify the sum of square distance of sample to the nearest cluster center. So here, now can you see here, student? See these distances. See this distance. This one is known as intra-cluster distances. So here, this is what inertia evaluates. So here, which value I had shown you, na? Sum of xi minus ci, xi minus ci, making the square of it from I is equal to 0 to n. So this one is this is what inertia evaluate. It tells how far the data points within the cluster are. These are the data point. So how far away from this centroid from the cluster are? So inertia actually calculates the sum of distance of all the data points within the cluster from the centroid of that cluster. Okay, now you are not going to make these formulas here internally working, I'm telling you. So basically this I'm going to use that to find out the elbow method here. So here I'm taking the same just to calculate the elbow method here. Here we created a WCSS as the blank list. What is the name given here? WCSS. So it means here, the value of this will be stored automatically. The value of this formulas will be stored automatically. Here. And for how many Ks? So basically for K in range 1 to 15, suppose here I want to try the K means on from 1 to 15 clusters. Means here, suppose I'm trying, see above I had given 3 number of clusters. So directly I had just create the 3 number of cluster in K means. But here what I'll do, just to work on elbow method, I'm giving the number of clusters from 1 to 15. Here I'm saying just do one thing. K means you start making the groups as per 1 to 15 number of clusters. Do this process repetitively, iteratively. Okay. So here for K in K, so here in K 15 times the iteration will go. So here what it will do, initially it will take the 1K, 2K, 3K, the value of 1, 2, 3, 4, that will be coming here. So here it will be taking the value of 1. So initially only one cluster will be created here. Then the value will be changing to this 2 here. So 2 clusters will be created by K means here. Later on, the value will be changed to 3. So 3 number of clusters will be created here. Then 4 number clusters would be created, 5 number, so 15 number. So basically this K will be keep on changing and this process will be make on. So that many number of clusters will be created by the K means. By why, what is happening with that? It is creating it as many as number of clusters we are providing it here, turn by turn. So what is happening with that now? Can you see here? This is returning, this KM is an instance, KM.fit, we are passing out the data frame. And here now this KM inertia is calculated. You know what is this? This inertia is the same, this formula is calculated internally. KM inertia is calculated with this formula with each K, and that the value will be appended in WCSS. So whatever calculated value here for the inertia will be written here. That would be appended here for the value of K1. Suppose whatever calculated value is there for the K1. So then if it is 2, so here for K2, this will be calculated for 2 clusters. This entire inertia will be calculated. This entire code will be executed. So the next WCSS value will be added here inside the list for 2 number of clusters. Then 3 numbers of cluster will be there. So this code will be calculating the inertia, but with having 3 numbers of clusters. So with 3 number of K, the new WCSS will be created. So this will be calculated every time. Then 4 number of clusters, so the new value. Then 5th number of clusters, so the new value. So this WCSS blank list will be filled up with different inertia level here. Different inertia level. So once we are having this entire data now, so what we'll do, we will be plotting this WCSS. So PLT dot plot K WCSS marker. Marker is nothing. I'm just creating a marker. I'd use this number of K WCSS. Here you can see KWCSS here. So you can see here, once I plotted it here now, you can see here, these are the various inertia values calculated. These inertia values are coming from this WCSS list is coming here. And these are the different K. At different K, different inertia levels are there, which are coming from this one. These are calculated here. So here now we need to work on elbow method. It is suggesting that how many number of clusters could be possible. So students, where elbow is there, this one is the elbow. Can you see here? This one is the elbow. So this is the number. This is 3. So here we can take number of clusters 3. So number of clusters 3. So here it is saying that for the provided data frame. So this data frame is which one? I'm passing this data frame, that one. Wait, this one is iris data frame. I'm just passing this DF now. This DF is what? This is the same DF. I'm passing it here. This DF. This DF, no, this DF I'm passing here. This one is the same iris data frame. I'm passing it here. So here it is saying that for this DF, for this provided DF, number of cluster will be 3. So the best suitable number of cluster could be 3. So once I identify the number of cluster could be 3, that is the best suitable. Now this number of 3 could be used here. Here. Number of cluster 3, I had used it now. This could be used. If my elbow method is giving number of cluster 4, so number of cluster 4 will be there. So that 4 I will use it here. So that we are doing the work with the help of elbow method. Technically, 2 methods I told you. See, earlier I'm taking the method here with just by discussion only. Idea generation I'm doing it here. Only idea generation I'm doing it just by discussing with the person or reading the documentation. Idea I'm taking how many clusters could be possible. But there I'm taking the elbow method. Elbow method is technically sounded. Means we are having certain proof that yeah, number of clusters 3 could be suitable there. So this is the elbow method here. Okay. So in this way we can work. So these are the basic 3 algorithms of unsupervised learning. Now here, I'm taking a case study for unsupervised learning. Just need to wait, let me open. Just wait, please. Okay, I'm taking a case study that how we can use this unsupervised learning. Okay, so here I'm taking one of the case study, very popular case study for customer segmentation. Customer segmentation means there is a mall, and in a mall, of course, regularly people are coming. Now there in a mall, the company wants to launch a new product. Now company wants to think it out that to which particular customers they should launch the product. To which particular customer they should make the target customers, to whom they can send the email, or SMS. Got the point? So that their product could be sold. So how they can identify those customers out of so many customers? So there we can use unsupervised learning to find out to make the groups and to find out the target customers. So this one is a very popular case study here. K means case study for the customer segmentation. So what is the context here? You can say here, this notebook is created for the learning purpose of the customer segmentation concept. This is also known as a market basket analysis. Here, you can see here that what is the content? You are owning a supermarket mall, and through a membership card, you have some basic data about the customer, like customer ID, age, gender, annual income, and spending score. So with that membership card, one is having an idea for the spending score and annual income also. Spending score is something you assign to the customer based on their defined parameter, like customer behavior and purchasing data, means how much frequently the customer is purchasing. Okay, now here, what is the problem statement? You own a mall and you want to understand the customer, like who can be easily converged so that the sense can be given to the marketing team and play the strategy accordingly, that who could be the targeted customer. So from here now, from membership cards, we can have any idea. From there, we are having an idea of customer behavior and purchasing data with the help of annual income and spending score. Okay. So here, by the end of this case study, you will be able to understand how to achieve the customer segmentation using ML. Who are your target customers with whom you can start making the marketing strategy easy to convert? How the marketing strategy works in real world with ML. So here I'm importing all the libraries. Also, I will be applying the k-means algorithm. So sklearn.cluster import k-means. K-means is the best, I'll tell you, in unsupervised learning, because here we can use the elbow method. With the help of elbow method, we can find out the number of clusters that we can put inside the k-means. That is the best. Yes, I feel k-means is the best. Okay. The rest are there, but the best one is a k-means in unsupervised I talk. Now I'm taking one of the data set, mallcustomers.csv. This one is a mallcustomers.csv. Inside this file, you can see here customer ID, gender, age, annual income, and spending score. So students, we need now only this data, nothing else. Only their annual income, idea, and spending score. These are not actual. These are the idea generation. Approximate. And these are the actual spending score. You can say 39, 6. You know, what does it 6 mean? 6 means the person is not purchasing data frequently. 40 means nearby, the person is purchasing not very frequently, means yeah, there is or she is purchasing. 94 means now the person is always purchasing something. They spend more. Here also they spend more. Here also they spend more. 3 means the person does not purchase any of the thing here. So here now, students, I need this annual income and spending score. So inside this data set, I took dataset.ilog, take all the rows from 3 to last. 3 to last means 0, 1, 2, 3, 3 to end. So annual income and spending score will come out. Annual income and spending score will come out. Now here, because I want to apply how many number of clusters I want to create. How can I get the idea? I'm using the elbow method. With the help of elbow method, I can find it out how many number of clusters I can create with the k-means here. So here I'm just writing sklearn.cluster import k-means. I created a blank list. I'd applied a for loop. Inside the k-means, I had provided number of cluster I. This I will be keep on changing because here this I, your for loop will be iterated 11 times. So 11 times k-means will be iterated. And this I will be keep on changing and fit, and here the inertia will be calculated 11 times. Once it is calculated, now here we are plotting it with the calculated inertia values here. Okay, there is one parameter, initialization is equal to k-means plus plus. This is nothing, this is a default. There in a earlier I had not given it, but that is still working there. That is a default. K-means plus plus is basically select the initial cluster center for k-means clustering in a smart way to speed up convergence. It means do this process on fast basis to make the clusters fastly. Once it is done here, we can see here in the elbow method that where is the elbow going on? You can see this is the elbow. See, this one is the elbow, this one. So here it says 5. 5 means here it is saying 5 number of clusters. 5 number of clusters. So here we are putting in k means number of clusters 5. 5 numbers of clusters we can put it to make the customer segmentation. Done. So 5 number of clusters I had provided it here. I'm saying in the k means number of clusters, just start creating a 5 number of cluster, fit predict, give all the X data. X data is what? Your spending score and annual income, that data. Here it is returning YK means these are the returnable. And you can see here labels here, these are the all returnable value. How we can understand this value? Let me tell you. Suppose you come here. Let me tell you what are these. These are the 5 groups because we had said now 5 groups are there. So the 5 groups are created here. So what are these 5 groups here? So basically, it is showing, yeah, I am able to identify 5 groups here. Can you see here? Students see 0, 0, 0, 0, 0, 0, 0. Some 0, 0 are coming here. These are group number 1. 0 belongs to group number 1. Then you can see here some 2, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. See here, see, 1, 1, 1. This 1 belongs to group number 2. Then here you can see 2, 2, 2, 2, 2, 2, 2, 2 always here. So 2 means group number 3 it is. Then you can see here 3, 2, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3, 3. So 3 means group number 3. And then comes your 4, 4, 4, 4, 4, 4, 4 here. So here, this is 4. This is group number 4. So here it is saying, I am able to identify 5 groups, 1 group, 2 group, 3 group, 4 group. Okay, 5 groups. So here, but they are represented with a 0, 1, 2, 3, just for the understanding purpose. Here it is giving you. No, you cannot take age column. No. You cannot take, because age does not give you any idea. Spending scores is spent. See, you are talking, you want to sell out your product. You are finding out the target customers So here the customer behavior pattern is getting analyzed. So their spending score and annual income will work. Their age will not work here. Here I am saying how to decide with maximum number of K. Sandra had shown you with the help of K elbow method here. The K elbow method here, elbow method you can use. From there you can find out where your this elbow is there na. This elbow is there. This elbow is there. So this is showing you 5 number. So it is saying 5 number of clusters. 5 number of clusters you have to provide. So here you have to provide number of clusters should be 5. It means the number of cluster which is coming into the elbow na, that number of cluster you have to provide inside the K, inside the K. Okay. For maximum value of K, you can give Sandra here, you can give 11, 15, that is your choice. You can give even 10, does not matter. But actually, na, you are looking the elbow only. You can go ahead with in range, na, you can give 10 values also. Because here the number of clusters 1, 2, 3, 4, 5, 6, 7, 8, up to 11 or 15 that will go. But let it go. You can give any value. You can give 10, 11, 15 in your range of K. But the major focus is that where is the elbow going on? That many number of clusters you have to give in K means. That is the overall purpose. You got the point now? Clear? So here, okay now? So here, 5 groups we are able to create. These are the various 5 cluster centers which was working. Okay. Now, because here you can see 5 groups are available. 0, 1, 2, 3, 4. Now I want to see which rows belongs to 0. Which row belongs to 1. Which row belongs to 2. Which row belongs to third group. In this way. So how? Here I can write it. You can write it X inside X, YK means is equal to 0. YK means is equal to 0. It means show me all the details of group number 0. Means here 0 belongs to group 1. 1 belongs to group 2. 2 belongs to group 3. 3 belongs to group 4. 4 belongs to group 5. So here now, suppose here I want to see that in this group now, how many rows belongs to 0 group. So here I am saying X, Y, K means is equal to 0. So here it is showing row number 1, row number 3, row number 5, 7, 9, 11, 13, 15, 17, 19, 20, 21, 27, 31. These row numbers belongs to 0 group. And you can see here, students, the 0 group spending score. Oh, wow. See, highest spending score is coming here. 81, 77, 76, 99, 79, 98. You know, what does it mean? It is showing that these row numbers, from with the help of row number, one can find out the customer ID. It means these people are having highest spending nature. They spend a lot. They purchase a lot. They do a lot of shopping because their spending score is very high. What's the point here? Because very high. So from here, 0 group is having very high purchasing. They are into the behavior of purchasing the product. They spend more. From here, we can conclude this. Now here, if I say, okay, tell me the row numbers which belongs to group 2. Group 2. So here I mentioned, just wait. Here I mentioned group 2, group 2. Can you see here YK means is equal to 2. So I want to see this one, this one. So here it is saying, see, row number 43, row number 46, row number 121, 126, 132. So these are the row numbers inside the data set. It is saying that these belongs to group number 2. But their spending score is a little bit less, 47, 42, 40, 58, 35. Here the spending scores are very good. It means group 0 is having very high spending score. Here I say this group, 0th group could be targeted for launching of new product. Means the sense can be given to the marketing team that you can send the promotional messages to the group 0, because the spending score is very high. They could be your target customers. That will work. Group 2 is semi. Group 1, if I want to see, show me the group 1, all the rows. So the row numbers means customer ID numbers could be traced. They are also having highest spending score, this one. So it means very good spending score. You can see here, no? Good spending score is there. So it means group number, group 0, group this one, 0 and 1. So it means group number 1 and group number 2, both are into the highest spending score. So they both could be target. Find out their customer ID, they both could be target. Any other you want to see, means in the similar way, you can find out group number 3 and group number 4 also. Now, the point is, I want to see this YK means is equal to 1 inside the data frame. Inside the data frame. So I'd load it here. This DD, I'd load it here. Which one? One number. So I'd load it here. Now, after that, what I did, I had stored them into the CSV file. dd.2 CSV file came in group2.csv. This one is a group2.csv. And if I want to store this particular model, which particular model? K means model. I want to store it. So that I'm using import pickle. File name I had given final K mean pickle, and I had just opened this particular file into the right binary mod, and I had stored this K means with the pickle.dump method. It means we can reuse this method in future. So we are saving the model to the local file system. Okay, so I had saved the group 2 in CSV mod, and here I had saved it. Now, this is the data set. Students, see, this is the data set: customer ID, gender, age, annual income, and spending score. Now, the point is here, how here this data set, now I'm just providing this data set inside the data frame. Now, how can I know that which customer ID belongs to which group? Here, all the customer ID are there. Suppose spending score 39, 81, 6, 77. Means here, how will I know that these belongs to which group? So that I can trace out the customer ID. So now I will be using this data. I will be adding one more inside this DS data frame now. Right now, customer ID, gender, age, annual income, and spending score is there. I will be adding one more, K means dot label, because there the group numbers are given. K means dot labels above I had created now, so that I'm taking. So here I had created one more column, DS group cluster. Here I just call pd.data frame. Data is equal to K means dot label. Here group numbers are given 0, 1, 2, 3, 4 from above. And once I had added, can you see here group cluster is added? This one has been added here. So here now you can see group customer ID 1, male at the age of 19. This is the annual income, spending score. He belongs to group cluster number 4. From here you can see customer ID 2 belongs to group 0. Customer ID 4 belongs to group 0. Got the point? This one, 196 number belongs to group 1. This one, 198 male belongs to group 1. So from here now one is getting, I had already told you group 0 and group 1, they are having very highest spending score. So they could be the target customers. So marketing team can find out these rows which are having group cluster with 0 and 1, find out the details of those customers and can send the promotional messages, product promotion messages to them, because there's a high possibilities of purchasing those products from these people. So in this way, marketing strategies could be done with the help of machine learning. This one is also known as a market basket analysis. Okay, so in this way, and here we can store this ds2.2 CSV with a CSV file name here, so that we can find out this CSV file directly from home page, can study the details. Marketing manager can study the entire details. If I want to load it back, I'd load it back here. These are the same one here, same file. Got the point here? And once it is done, if I want to make the group of that, I want to see it here, see here, just wait. You can see here. I just plotted this one. Here it is showing you 5 groups. Group 1, group 2, group 3, group 4, group 5 groups, and these are the centroid. I think 5 groups are there. Like 5, like 0th group, first group, second group, third group, fourth group. So 5 groups are there. Okay, now how it is created? Just by scatter plot. Here I had taken that scatter plot, I had just drawn it here. You can see here. Figure size, I had increased it here. plt.figure size here, plt.scatter. You should know that inside the scatter method here, whenever we are giving here scatter method, inside the scatter method, we need X and Y. Only this. So here X, I had given annual income. Okay. And I need spending score. So here annual income and here spending score. These 2 data I needed. So all the details I had given. X, Y, K means is equal to 0. First group, take the 0th group. What? It's annual income in X, and in Y, take this YK means 0, and it's spending score. Okay, so this one is for the 0th group, then for first group, then for second group, then for third group, then for fourth group. Okay, because it is going to create a mix. And this S is what? This S is this S. This S is size of this circle. You can see this circles now. So S is the marker size. Marker size means this circle size. S100 means size. If you reduce it 50, 80, it will be small circle. Okay. C is equal to colors I chosen and the label cluster 1, cluster 2, cluster 3, cluster 4 in this way. And then here, these I had used for various cluster centers here. In this way we create it. You need to study on our own. So this one is your unsupervised learning basically. So this one is overall for your unsupervised learning. Okay then. So this one is overall your unsupervised learning. Now your ML is done completely from my side. That's all for today. Thank you. Thank you very much. Your ML is completed now. Thank you very much. Thank you. If you have any question, you can ask. Otherwise, you can leave because this is your entire ML here. For the next, you will be receiving the mails. For the next, you will be receiving the mails. Yeah, this is my last class. Yeah. Thank you. Thank you. Yeah. Thank you. Thank you. Thank you. Okay. Thank you very much. You will be receiving a mail. You will be receiving a mail. You will be receiving a mail.